Okay, greetings, math people. Today we're going to be deriving the law of cosines. So let's go ahead and get right into it.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relaxed one.
All right, so the law of cosines is a formula, if you will, that allows you to solve an oblique triangle. An oblique triangle is a non-right triangle. So of course we can solve right triangles given the conditions with stuff like the Pythagorean theorem or just basic trigonometric ratios. So the law of cosines allows us to solve oblique triangles given certain conditions. There's also the law of sines, which solves oblique triangles in different conditions. So let's just sketch an oblique triangle. So I'm going to try to make this oblique triangle not to look like an equilateral triangle, because this is just any oblique triangle. Could be acute, could be obtuse, just any oblique triangle. And I'm going to label the sides, label these angles A, B, and C. And then the corresponding sides opposite of each angles with the same letter. So here is side A, here is side B, and here is side C. And I'm going to put this just to illustrate that side C is all of this. And the reason I'm not putting that for the other two sides is because they're going to remain intact. But I'm going to do a little dissecting with side C. All right. So albeit this is a way to solve an oblique or non-right triangle, it's still based fundamentally on right triangle trigonometry. So to get the relationship that we need for the law of cosines, we're going to have to construct a right triangle. So I'll draw some line here that goes perpendicular to AB, perpendicular to the base of the triangle, and we'll call that H for the height. Similarly, I'm going to call this side of this newly constructed right triangle, I'm going to call this length K. So the length from here to here is K. Now remember, the whole length is C, and so therefore the length from here to here is C minus K. So this length is C minus K. All right, so it's called the law of cosine. So we're going to do something with cosine. And basically in this case, I'm going to find a formula for finding side A. And so I'm going to use angle A to pull this off. So I'm going to do the cosine of angle A. So the cosine of angle A, cosine, as you know, is adjacent over hypotenuse, would be C minus K over B. Which means if I take this and solve for K, and I'll let you know in a second why I really want to solve for K. If I take this expression and solve for K, C minus K would be B cosine A, which means K would be C minus B cosine A. All right, so that's useful information that we'll use momentarily. I'm also going to find the sine of angle A. I know it's called the law of cosines, but I need to utilize sine as well. And sine, of course, is opposite over hypotenuse. So the sine of angle A would be H over B, which means that H would equal B times the sine of A. All right, so I got two critical values that I'm going to utilize, and that is the value for K and also the value for H. Now, I mentioned I'm trying to get a formula for A, so I'm going to do something that utilizes side A. And so what I'm going to do is the Pythagorean theorem. So this indeed is a right triangle. So the Pythagorean theorem tells me that K squared plus H squared equals A squared. And so K squared plus H squared equals A squared. Now what I'm going to do, and you see these guys circled, is I'm going to substitute for K C minus B cosine A, and I'm going to substitute for H B sine A, and then simplify the expression and see what beauty follows. So let me do this on a separate sheet. And so again, I'm going to replace this k with c minus b cosine a. I'm going to replace this h with b sine a. And of course, they're both being squared. And this is going to be a formula for a. So I'm going to put the a squared in front of these two. So let me just rewrite the last statement. So a squared is k squared plus h squared. And let me just write to the side the values we already had for k and h. So just going to write here that k was c minus b cosine a, and that h was b sine a. All right. So let's go ahead and do the substitution. So then a squared would be c minus b cosine a squared plus b sine a squared, b sine a squared. All right, so from here, we're just going to do a little algebra. We're going to square these and use some trig identities. We'll use one trig identity to simplify. So let me go ahead and square this. So if I square this, just binomial expansion, it would be c squared minus 2bc cosine a plus b squared cosine squared a. And so that's merely the expansion of this guy. Now squaring this is a lot more simpler. Squaring this is simply b squared sine squared a, b squared sine squared a. All right. So what I would like to do is, you notice both these terms have a b squared, and I'm going to factor b squared out if you will allow me. So a squared will be c squared minus 2bc cosine a plus b squared times, so I'm factoring b squared out, cosine squared a plus sine squared a. Now, what you have right here is a Pythagorean trigonometric identity where cosine squared theta plus sine squared theta equals 1. So cosine squared a plus sine squared a is going to equal 1. And so 1, so this whole guy becomes 1. And of course, 1 times b squared is simply b squared. And so this is our actual relationship here. But I'm going to move this b squared. Again, this is going to turn to 1. B squared times 1 is b squared. I'm just going to move this b squared to the front. And what I get is that a squared equals b squared plus c squared minus 2bc times the cosine of a. And that pretty much is the law of cosines, at least for a, as you'll see in most textbooks. What I like to do, since we're actually solving for a and not solving for a squared in most cases, I just like to lastly just take the square root, where a is the square root of b squared plus c squared minus 2bc times the cosine of a. All right, so that's the law of cosines relationship to find side A. And the interesting thing to note here, if I'm finding side A by the law of cosines, the angle I'm going to be using is angle A. And additionally, the sides that are in the formula are sides B and C. So in order to find side A using the law of cosines, I need to know the other two sides and the angle that's opposite of the particular angle. And so with that understanding, then the formula for the other sides is by a similar logic. So again, to find side A, I have to use the angle that's opposite it and the other two sides. So let me just rewrite that formula. So what we just said is that A was the square root of b squared plus c squared minus 2bc times the cosine of A. And so for instance, if I wanted to find angle B, side B, excuse me, I would use the other two sides, which are A and C. So it's a squared plus c squared minus 2ac times the cosine, and I'll use the angle opposite B, so times the cosine of B. And then lastly, if I wanted to find side C, then I would use the other two sides besides C, which would be A and B, so a squared plus b squared minus 2ab times the cosine of the angle opposite C, which would be big C. So there you have it. Those are our 3 formulas for the law of cosines. Hope you enjoyed deriving the law of cosines formulas, and we will see you next time.
Specialized in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.